Dear students, welcome to my classroom. In the present part of the chapter sets, we are going to learn about some new concepts like null set or empty set, universal set, subset, and Venn diagram. So, so first let us see what is empty set or null set. A set which does not contain any element is called an empty set or a null set. That is, there is no element should present in the set. That is, the number of elements in a set is 0, then the set is said to be empty set or null set. So let us see some examples for empty sets. Okay, so first one is, so R is a set of x such that x is a natural number between 5 and 6. Okay, so in this set, the elements in the set R are the natural numbers between 5 and 6. Is there any natural number between 5 and 6? Do you think so? So there is no natural number between 5 and 6. The natural number after 5 is 6, and the natural number 6 before 6 is 5. So there is no natural numbers between 5 and 6. So R is a null set. And see one more example. A is equal to set of x such that x is a vowel in the word rhythm. So in the word rhythm, there are no vowels. So the set containing vowels in the word rhythm is an empty set. Okay. So here A is an empty set. So take one more example. M is equal to set of x such that x plus 3 equal to 0 and x belongs to W. Here W means set of whole numbers. So if x plus 3 is equal to 0, it is clearly x is equal to minus 3. Is minus 3 belongs to whole numbers? No. So whole numbers are starts from 0. So there are no negative numbers in whole numbers. So the value satisfying x in this equation are not present in the set M. So here M is an empty set. Okay, because minus 3 not present in whole numbers. Next one is S is equal to x such that x is an odd number whose unit digit is 2. So we know that all the odd numbers contains uh, either 1 or 3 or 5 or 7 or 9 in its units place, isn't it? The numbers which are ending with 1, 3, 5, 7 or 9 are odd numbers. So here we have the odd numbers whose units digit is 2. So it is impossible so that the set S is an empty set, because there are no elements satisfying this condition. So the set S is an empty set. Okay. So we denote empty set by the Greek letter phi. So you can see the letter phi here. So we denote the empty set by the Greek letter phi, or we can denote by empty curly braces also. Okay, so we can denote empty set by either the letter phi or empty curly brackets. Okay, so number of elements in null set is 0. It is clear. Okay, but here we can see some sets which are non-empty sets. In first one we have 5 in a set. So it is non-empty set because there is an element in the set, and the element is there 5. So the first one is non-empty set. as well as in second set also we have an empty set inside a set. That is, the empty set is the element of set. So the second one is also non-empty set, and third one is clearly non-empty set because there is 0 in the set. 0 is an element of the set, so it is also non-empty sets. Okay, and now let's see universal set. So a universal set is the collection of all objects in a particular context. That is, the set universal set depends upon the context. So for example, if we study about the students of a school, the set of all students in that school is universal set. Okay, so if we study about the students of school, the set of all students. So in this context, we are studying about the students of school. So the collection of all students in that school is universal set. And similarly, if we study about the various groups of people of a state, the set of all people in that state is universal set. Okay, like that, the universal set depends upon the context we are dealing. Okay, so universal set is denoted by the Greek letter mu. This letter is called mu. Likewise, this letter is also a Greek letter, which is called as mu, or we can denote the universal set also by a letter like capital U. Okay, so we can denote in both ways, and we use the rectangles for representing universal sets in Venn diagrams. Later we discuss about Venn diagrams, and generally we use rectangles for representing universal sets in Venn diagrams. Okay, next one is subset. If all elements of set A are present in set B, then A is said to be subset of B. That is, if all elements of set A are present in set B, then A is said to subset of B. Every element of set A must present in set B. In that case only, set A is said to be subset of set B. For example, if we take A equal to set of elements 2 and 4, and B is equal to set of elements 1, 2, 3 and 4. So as the all elements of A, that is both 2 and 4 are present in B, then we can say that A is subset of B. Okay, here the elements 2 and 4 which are present in A are also present in B. So here A is subset of B. Also, if A is set of all English alphabet and B is set of vowels in English alphabet, then B is subset of A, because all the vowels are present in English alphabet. So the elements are all elements of set V are present in set A, so that the set V is a subset of set A. In another example, set of natural numbers n is subset of set of integers R, because we know all natural numbers are present in integers. Natural numbers are starts from 1 and continues as like 1, 2, 3, 4 like that, and integers starts from integers are from both we have both negative integers, positive integers, and in positive integers we have natural numbers. So that natural numbers n is subset of integers set R. Okay, and if set A is subset of set B, then we write it as A subset to B like this. This is the symbol of subset. Okay, if we write A subset to B, it means that set A is subset of set B and B has more elements than A. So if we write a symbol like is equal to, then A is either subset or is equal to B. And if it's write only without the equal symbol, then set B has more elements than A, and we usually use this second symbol only, that is A, a subset of B. Okay, Generally we don't use A is subset R is equal to B. We use only A subset B in this chapter. Okay, and if set A is not subset of B, then we write like this: A is not subset of, that is, we cross with a line to the symbol subset. Okay, and now null set is subset of every set. Null set means empty set. Empty set is subset of every set, because we know that there are no elements present in null set. So obviously every element of null set is present in every non-empty non-empty set. So that null set is subset of every set. So that is, if A is a non-empty set and phi is a null set, then we write phi is subset of A. In that way, every set has at least one subset in the form of null set. Okay, and every set is a subset of itself also. For example, if A is equal set of 1 to 3, and again we are taking A is equal 1 to 3. So elements of all elements of set A are present in itself. So we can write A is subset of itself. So A is subset to A. Okay, and we know that set of natural numbers is subset to set of whole numbers, and set of whole numbers is subset to set of integers, and set of integers is subset to set of rational numbers, and set of rational numbers is subset to set of real numbers. Okay, so we have seen the figure in real numbers also. So this is very most important, we have to remember. Okay, and now let us see how many subsets are possible for a set. So take set, possible subsets, and number of possible subsets. So first take empty set. So we know that every set is subset of itself. In that way, empty set also subset of itself. So it's empty set, subset of empty set is itself, and so the number of possible subsets is 1. And take a set X, set of element X. So let us see which are the possible subsets for the set of X. So first subset is null set, because we know that a null set is subset of every set, and also we know that every set is subset of itself. In that way, set of X is subset of given set. So here we have two subsets, and now take a set of two elements X and Y. So let us see how many sets are how many possible subsets are there for set X and Y. So first one is null set, second one is the set containing element X, because the element X is present in the set X and Y, set of X and Y, and second one is set of Y, and third one is set of X and Y. So these four are the possible subsets of set of elements X and Y. So the number of possible subsets is 4. And take now the set of three elements X, Y, and Z. Now the possible subsets are empty set. So set of single elements X, Y, Z, and set of two elements X comma Y, Y comma Z, X comma Z, and given given self itself X, Y, and Z. So in that way we have 1, 2, 3, 4, 5, 6, 7, 8. So in that way we have 8 subsets. So if we can observe that for 0 number of elements we have 2 power 0 subsets, and for the sets having one element we have 2 power 1 subsets. And for the set containing 2 elements, we have subsets 2 power 2. And for the set containing 3 elements, we have 2 power 3 subsets. So in that way, if the number of elements in a set is n, then the number of possible subsets for the set is 2 power n. So we have to remember this result because it is very important for objective type of questions. So if the number of elements is n, then the number of possible subsets for the set is 2 power n. That is, if number of elements is 4, the number of possible subsets is 2 power 4, that is 16, like that. Okay. Now let us solve some problems under the title do this. If A is equal to set of elements 1, 2, 3, 4, B equal to set of elements 2, 4, C is equal to set of elements 1, 2, 3, 4 and 7, and 5 is a null set, fill in the blanks with subset or not subset. Okay. So we have 6 blanks here, and we have to fill these blanks with either subset or non-subset. So take first one, A blank B. So we have to check that whether A is subset of B or not subset of B. So are all elements present in A are present in B? No, because the elements 1 and 3 are not present in B. So the all elements of set A are not present in set B. So we can write A is not subset of B. Okay. Second one, take second one. C blank A. C is the set of elements of 1, 2, 3, 4 and 7, and A is the set of elements of 1, 2, 3 and 4. So all the elements of C are not present in A because there is an element 7 in C which is not present in A. So we can write C is not subset of A. Now consider about 3. B blank A. Are all elements present in B are present in A? Yes. We have 2 elements in B, 2 and 4, which are also present in A. That is, all elements in set B are present in set A also. So B is a subset of A. So we can write the symbol B is subset of A. And similarly, A blank C. So all elements of set A are present in set B. We can observe that. So A is subset of C. And also all the elements of set B are present in set C. So B is also subset of C. And sixth one we have 5, that is null set blank A. And we know that 5 is subset of every non-empty set. Here A is also a non-empty set. So of course 5 is subset of empty set also, because 5 is empty set itself. So 5 is a subset of A is also. So we can fill with subset. So let us see second one. State which of the following statement are true. First one. So observe these 3. So first one is null set equal to 5. Second one is 5 equal to 0. Third one is 0 is equal to set of 0. So what do you think that which statement is true? First statement is true, because here we know that empty set is represented by 5. In first one we have empty set and it is given that empty set is equal to 5. So first one is true. And second one is 5 is 0. So 5 is an empty set, but 0 is an element. So a set never be equal to an element. So it is false. And also third one is also we have 0 on left side and a set of element 0 on right side, which cannot be equal. So it is also false. Okay. Now we have some problems under the title. Try this. So first one, A is equal to set of quadrilaterals, B is equal to set of square, rectangle, trapezium, rhombus. State whether A subset to B or B subset to A. Justify your answer. So in this, it is given that A is set of all quadrilaterals. B is set of some specific quadrilaterals only. They are square, rectangle, trapezium, rhombus. That is all these elements in B are quadrilaterals. But all quadrilaterals in A need not to be square, a rectangle, a trapezium, a rhombus. So here B is subset to A. That is all the elements present in B are present in A also. But all the elements in present in A are not present in B. So here A is subset to B. So we can write in set A we have all types of quadrilaterals including square, rectangle, trapezium and rhombus. That is all elements of set B are present in set A. So B is subset to A. Okay. Second one. If A is a set of elements A, B, C, D, how many subsets does the set A have? As we have seen earlier, if the number of elements in a set is n, the number of possible subsets is 2 power n. As here we have 4 options 5, 6, 16, 65. The number of subsets for set A is 2 power 4 as the number of elements in set A is 4. And we know that 2 power 4 is 16. So the answer is 16. Okay. Now take third one. P is the set of factors of 5. Q is the set of factors of 25. And R is the set of factors of 125. Which one of the following is false? So first one is P is subset to Q. And option B is Q subset to R. Option C is R subset to P. Option D is P subset to R. So here P is the set of factors of 5. We know that the set of the factors of 5 are 1 and 5 only. So P is the set of elements 1, 5. And similarly Q is the set of factors of 25. So that the Q is equal set of 1, 5 and 25. And R is the set of factors of set of elements 1, 5, 25 and 125. Now let us check which of these statements are false. So first one, it is given that P is subset to Q. So here we can observe that all the elements in P are present in Q also. So P is subset to Q. So first one is true statement. So let us check the second one. Q subset to R. Yes, Q is subset to R also because all the elements in Q are present in R also. So Q is subset to R is also true statement. And consider about third one. R subset to P. Are all the elements present in R also present in P? No, because 25 and 125 are not present in P. So R is not subset of P, but it is given that R is subset of P. So our required answer, which is false, is option C. Let us check the D also. P subset to R. So P subset to R is true. Okay. Next one, fourth one. A is the set of prime numbers less than 10. B is the set of odd numbers less than 10. And C is the set of even numbers less than 10. Which of the following statements are true? So here given that A subset to B, B subset to A subset to C subset to A, B subset to C and 5 subset to A. So let us see what are the elements of set A, B and C. Here A is the set of prime numbers less than 10. In that way A is set of elements 2, 3, 5 and 7. and B is the set of odd numbers less than 10. You know clearly the elements 1, 3, 5, 7, 9 are the odd numbers less than 10, and C is the set of even numbers less than 10. So C is set of elements 2, 4, 6, 8. So let us see which statements are true. A subset to B. Is A subset to B here? No, because 2 is not present in B. The element 2 in A is not present in B. So A subset to B is false. Okay. So here we have only 5 subset to A is right. Let us see why. B is subset to A. So set B is contains element 1, 3, 5, 7, 9, and set A contains 2, 3, 5, 7. So element 1 in B is not present in A. So B is not subset to A. So second one is also not true. And A subset to C. So we can check that A is not subset to C because 3, 5 and 7 are not present in C. And C subset to is also a not true because the elements 4, 6, 8 are not present in A, and B subset to C and 1, 3, 5, 7, 9 are not present in C, so that B is subset to C also not true. And we have the last one 5 subset to A, which is only correct statement because every uh, empty set is a subset of every set. Okay, so in that way the last option, only sixth option, is true. Okay, now let us see Venn diagrams. What is Venn diagram? So a diagram representing sets pictorially as circles or closed curves within an enclosing rectangle are called Venn-Euler diagram or simply Venn diagram. Okay, so a diagram which represents sets pictorially using circles or closed curves which are enclosed in a rectangle are called Venn diagrams. Let us see some examples. So A is equal to set of elements 2, 4, 6, 8, 10, and universal set mu is set of elements from 1 to 10. Then Venn diagram is as follows. So first we draw rectangle which represents universal set, and in that we have set A, and set A contains 2, 4, 6, 8, 10. So first mark the elements in set A 2, 4, 6, 8, 10, and the remaining elements are outside of the A which are in universal set like this 1, 3, 5, 7, 9. So here A contains only 2, 4, 6, 8, 10, and universal set contains all the elements 1, 2, 3, 4, 5, 6, 7, 8, 10, 9 and 10. So like this we represent Venn diagram. Let us see one more example. Another example is A is equal to set of elements 2, 4, 6, 8, 10. B is equal to set of elements 4 and 6. Mu is the set of elements from 1 to 10. So here we can observe that the set B is the subset of A because all the elements in set B, that is 4 and 6, are present in set A also. So that B is subset of A. In such cases, we draw the Venn diagrams as like this. So first we draw universal set with the rectangle, and A is the set contains 2, 4, 6, 8 and 10, and the remaining elements are 1, 3, 5, 7, 9 which are outside here. And now there is another set we have to represent set B. Okay, so like this. Now set B is entirely lies in the set A because B is the subset of A, and um, both A and B are subsets of universal set. Okay, so every set is subset of universal set. We must remember that. Okay, all the sets are subsets of universal sets. So let us see one more example. A is set of 1, 2, 3, 4. B is set of elements 2, 4, 6 and 8. So then Venn diagram is as follows. So here we can observe that there are two elements are common in both set A and set B. Okay, they are 2 and 4. So in this case, we draw Venn diagrams like this. So here is no information about universal set. So just we denote the rectangle by mu only. So as we have no information about universal set. So in this case, we draw Venn diagrams of sets A and B like this. We have common area because we have common elements in A and B. We need to draw common area for both A and B. And first we um, mark the elements 2 and 4 in this common area because the elements 2 and 4 are common elements in both A and B, and remaining elements in A are 1 and 3. So we mark the elements 1 and 3 like this, and remaining elements of B are 6 and 8. So here the elements present in only A are 1 and 3, and the elements in present in set B only are 6 and 8, and the elements present in both A and B are 2 and 4. Okay, so simply we can explain the set nature of set A and set B using Venn diagrams. Okay, students. In next class, we are going to learn about operations on sets like union and intersection, and also we are going to learn about the difference of sets. So we shall meet in next class. Until then, see you. Bye.